So first of all, once you had a wireless system, the thing is how secure is the wireless? There's been talks for years and years about how secure is wireless compared to hardwire, etc. So as technology evolves, there's a lot more changes in wireless systems that show, that virtually make it look a lot more like a hardwired system. So let's have a look at what's different between the one-way wireless that we've been using for years and years and everyone else is using, and the two-way wireless. Is first of all that with the Ness TWR, it uses a cutting-edge features including encryption, frequency hopping, UL-approved jamming detection, so if someone tries to jam that signal, and protection against interfering, hacking and jamming, as I was saying. With every two-way wireless device, when a transmitter, whether it be a reed switch, whether it be a PIR, when they activate, the receiver, which is now a transceiver, gets a signal, sends a signal back to the transmission device and said, thanks mate, I've got that signal. So once you then receives the signal, then the transmitter knows, right, stop transmitting to save battery life. All the transmission devices now, whether it be a reed switch, PIR, radio key, etc., they've still got LEDs on them, but with the one-way, what we're familiar with is when you transmit, example, when we open the reed switch or whatever, or detector detects, the LED comes on. With the two-way, it works the opposite. The LED comes on when it receives the signal back from the transceiver. So if we've got a reed switch and we move the magnet away, then the LED will come on when it gets a signal back from the transceiver, not when it's transmitting. So if it gets a green LED pretty well instantly or maybe 1.5 a second later, then getting the green LED comes on, say 4 or 5, 6 seconds later, you know that it got the signal from the transceiver. However, it did take a while to get there in the sense that it might be a radio interference. It could be also that it's a long way away from there. It took a while to get to the transmitter. If it gets maybe 8 or 10 seconds later, you get a red LED coming up. Red LED said, hey, we're transmitted, but we never got a receipt back from the receiver. So green means it got the signal. Red means in a reed switch or PIR didn't get the message back from the transceiver, therefore the message didn't come through. So you might have to look at the range, look at putting another receiver or something in there. And if it takes a long time for the green LED, the same scenario. It got the signal back, but it took a long while to get to the transceiver. So you got some diagnostics or some feedback of how good it is. The other thing when walk testing motion sensors, the easiest way to do that is what we've added is when you go into walk test on the M1 keypad, as you walk in front of the motion detector, turns the night light on. So rather than trying to see whether obviously the M1 gets a signal, but so you know where it detected, the night light flashes on to make it a lot easier to see whether rather than the green or red LED. So that just helps for walk testing. The other thing with the night light or the security light on there, obviously if it's dark and someone walks in front of the detector in a really dark room, that night light or security light comes on, to help people walk through, but you've now got control from the M1. The same with the radio key fob. The radio key fob has got the green and red LED. Except the red LED is used for status. It's not coming on red LED to say that it didn't get a signal back from the transceiver. But what happens is when you arm the system, the LED will go red. So as you arm it, it will then go to the transceiver. Transceiver sends the signal back and brings a red LED on to say, yep, we're armed. If we disarm the system and we get a green LED coming up, the green LED is telling it that the system's disarmed. You can instantly tell if the system armed and disarmed without having to chirp sirens, etc. You'll also notice the bottom left-hand corner, button 3 of the transmitter, the radio key, is an information button. If you push that information button, the LED will come on and tell you the status of the system. Again, red LED comes up to say the system's armed. Green LED comes up to say it's disarmed. If it flashes red, then you know that's armed with an alarm activated in that area. There's a lot of advantages, with the two-way, and if we now have a look at each individual device, that will even give us a little bit more insight. With the one-way systems, when a device activates, what we have to do is send about 20 signals to the receiver and at full power, hoping that one of them gets through. And we've no idea whether it got through or not, except detection device. We do from the panel, we know if it didn't go into alarm, but you've got no diagnostics. But as we mentioned, with the two-way, every time a door is open, it will then send a signal, waits till it gets a signal back from the transceiver. If it doesn't get the signal back, then what it does, it then frequency hops, changes the frequency to a different frequency to try to get through, and at a different power level. So with one way, you're transmitting about 20 signals at full power. The two-way, you're transmitting one signal at low power, waiting for a receipt. If it doesn't get a receipt back, it then transmits at different frequency at a slightly higher power. So therefore, you're getting a lot better battery life than what you are over one way. So some of the differences is the positive signal acknowledgement. We're running up at the 900 meg range, so rather than 304 meg, we're running at 902 to 928, so frequency hopping, if it didn't get through at, say, 902, it'll then change the frequency randomly to a different frequency to get through. We've got bicolor LEDs, so you know the red or green. So if it's a PIR, if it's a read switch, red means it didn't get through, green means it got the signal. With a radio key, red means the panel's armed, green means it's disarmed. So just on that, you just got to remember that when you're activating it, don't think, oh, I've got a faulty battery, I've got a faulty transmitter, because when you open it, the LED doesn't come on, then that's the reason why. And we also adjust the power level to prolong the battery life. And again, we'll cover that a little bit later near the end. If we now have a look at the two-way transceiver itself, or the radio receiver, each radio receiver will support 144 zones of wireless. The receiver sits on the M1 data bus, and you can add an additional 3 transceivers to cover large areas. One thing that you must do with the two-way, and we've been telling this for the last 3 or 4 years with the one-way, was that all the radio receivers or transceivers must be addressed at address number 2. And if you've got subsequent transceivers, you've got more than one receiver on there, that must be at address 3, 4 and 5. You can't put it up at address 6, 7, 8 or whatever, one that doesn't allow you to address it, but 2, because we're transmitting back, it must be at address 2, 3, etc. So therefore, if you've got any hardwired devices, you can't then, and you want to put radio receivers, you can't have the hardwired set for address 2, so you can't have them at zone 17 to 32, etc. They must be then pushed up at a higher zone number. So even if you're planning, if a customer is looking at putting a radio device in the future, it's always a good idea to leave at least address 2, if not 2 and 3 spare, so you can put that on there. When we look at the two-way transceivers, there's some diagnostics on there which makes life a lot easier. First of all, on the right-hand side, you'll see that there's the 4-way terminal block. That's for the data bus. Just behind that, we've got the termination, so if it's the last one on the 485 bus, then you've got to terminate it. The LED just above there just tells we've got activity on the bus, so it's piling on the bus, that's normal. Over the left-hand side down the bottom, we've got the dip switches, so you can address that to address 2, 3, 4 or 5, depending which one you're putting on. But the other handy ones that are the top left LEDs. First of all, you've got the status LED. That should blink continuously about 1 per second. The bottom one, all RF, that's a yellow LED, so that will flash when it picks up a signal at the 902 to 928 megahertz range. So if you open a read switch, activate a PIR or radio key, etc., then that all RF light should come on. If it doesn't come on, you know that maybe it's a one-way you're trying to get into the two-way, etc., or it's different, or it's dead or something like that. So that should come on. If it's learnt into the M1, then the green LED in the middle, learnt RF, should come on. So for fault finding or for testing, straight away you know, one, did the transceiver get the signal, because the all RF would come on, and if it's learnt in, then the learnt RF would come on as well. And obviously when that comes on, it's transmitting back to your detection device to say, yes, it worked. There's the antenna. It's a little ceramic antenna. So the antenna's on there. There's no need to expand it, because you'll get a lot better radio range than what you would with the one-way. Once we tell you that we've been testing this and we're getting in an open field 2 to 250 metre radio range, then next thing you know, people can translate that 200 metres to 200 kilometres. So all we're saying is that it will still be within the industry standard 50 metres, but you'll be really surprised at the range that you are getting this. You'd probably get twice the range as what you can out of the M1 out of one-way, I should say. So you'll get a hell of a lot better range out of this. So there's no need to, put an extended antenna on. You're still going to get a lot better range out of this than what you would one-way and the antenna. But a couple of things to watch is that make sure you don't put this in the M1 metal housing, of course, because you'll shield the signal with the metal housing. And also keep the transceiver at least 1 metre away from the panel and the keypad, the same as we do with the one-way, because that can affect the range as well. So it does come in this plastic housing, so you can mount that wherever you wish. One question there I just noticed, and we'll get to the questions at the end. What's the distance between the M1 and the transceiver? It's typical the RS485 data bus range, so you can go typically 1.2 kilometres away from the M1, and you can put multiple transceivers on there. So you can put 4 transceivers on the system. So if you've got, a large factory, for example, you can put multiple on the one job. If you've got a large residential where maybe they've got 3 or 4 stories and there's concrete slab with Rio between to blind the signal, you could put a transceiver on each floor. So you drop it and multi-drop off, so you can get extra distance that way as well. As we mentioned with the radio key, you've got the LED to tell you if the system's armed, disarmed, or if it flashes, it's telling whether it's armed but in alarm. You've also got the inquiry button, and it's much the same as a one-way. Any button can be programmed to do anything. So button 1 on one radio key can do something totally different from button 1 on another radio key, etc. So you can fully program that. Now, the inquiry button, as I said, if you push that, it will tell the system if it's armed or disarmed. So in a way, the 4-button key then becomes 3 buttons for activation of devices, with the 4th button, the inquiry button, being tell you the system status. If you want to use that inquiry button to activate something, such as to open a gate or door or whatever you want it to do, you've got to push and hold that button for at least 4 seconds, and then it will activate what the button does. If you just push it, the LED will come on to say if the system's armed or disarmed. So a quick push will give you the status. Push and hold will then activate that device. The other thing with the radio key is that it now is, you can snap it open. There's a little slot there, you can put a little screwdriver blade to pry it open to change the battery. So it's not like our other ones that are ultrasonically welded, so you can go swimming with them, put them in the bottom of a swimming pool and they'll still work. These ones, although they're still quite waterproof, you can open them and replace the batteries with. The next device that we can put on is our slim radio read or slim line door radio sensor. So it's a slim line device. As you notice, it's a lot smaller than the one-way. It's much the same as a hardwired magnet with the device, and then you've got a smaller magnet on the other side. It runs with a 3.6 lithium battery, and as I said, you've got the LED in the middle there. So when the green LED comes up to know that it got the transceiver signal back. Red LED comes on to tell you that if it didn't get the signal back from the transceiver. With radio read, they're also tampered for front and back. So when you get the radio read, within the little kit that comes with them, with the screws, etc., there's this little plastic device. So if you want to use a tamper switch for the read switch, that little plastic grommet sits in the read switch, so it sits in like so, showing there in the middle. It has got a little holder there that does hold it into place. So when you push that through, the other end of it, as shown there, will come through the back of the reed. So when that is mounted onto the frame of the door, then of course it then pushes that little section up, and when that section up, it goes around the tamper part of the device, which then will tell the reed switch that it's been activated for tamper. So if someone takes the cover off or rips it off the wall, etc., you're going to have an alarm that's activated. So if someone pulls the reed off and walks away with it, as well as they've got supervision for it, of course, you've also got that tamper for front and rear. If you don't want to use that tamper bracket, that's fine. You just don't use it, and this reed switch is smart enough to know that it's never been activated. If, for example, you did that on the bench, you were testing with it and then said, I don't want to use it, what you've got to do is just power the reed switch down, wait about 30 seconds, power it back up, and the reed switch knows. But as soon as that tamper is activated, it knows that now it should be activated all the time. We've also got the micro reed, which is in the same housing as our current micro reed. The radio range for this will be a lot less than what you have with the slimline, being a smaller device and smaller antenna, but is a very low profile device. Again, you've got the green and red LED on there, but there's no tamper on this one. Coming soon, probably looking at about 2 months' time, will be a 3-zone sensor. So it's in a larger housing, much the same size housing as what our current one-way read is, but it's got 3 zone inputs there. two zones. One would be the read switch on the device itself is one zone, and then you've got loop 1 and loop 3, making it a 3-zone sensor. So therefore, you may not want to use the read switch on board, maybe you do, but you can then put any hardwired device you want into this to have anything hardwired. Maybe a roller shutter contact, you can hardwire a roller shutter contact into one of that LP1 or LP3 and then activate that. So there's a little 3-zone sensor that's coming that does it will do anything, and it's tampered as well, the same as what the slimline one was. We've also got PIR, which is a standard and a PET detector version. So they will both activate. Obviously, it's a 15-metre detector with the creep zone and the security nightlight on there. If we have a look inside the detector itself, the dip switches that are on the sensor itself, you've got the pulse count, 1 to 2, 3 to 4 pulse. You've got the range, the detection range out the front, being low and high. I think high is about 12 metres, low is about 8 metre range. You've also got a sleep cycle on this. So you can put it on long sleep count, which is typically your 4-minute sleep PIR sleep time, or you can put it on short, which therefore works much the same as a hardwired detector does. You've also got to want the security nightlight on. So maybe in a bedroom, you may not want that security light coming on, so if someone turns over in bed or whatever, the light's not going to come on, you can turn it off. And if you put it on, you then also get control of it from the M1, which we'll show you in a moment. And then you've got your RF acknowledge LED. So do you want the red and green LED to come on? If you put it on yes, then obviously as you move in front of it, the green LED will come on to say it's been detected and it's activated from the transceiver. Now, one of the things I mentioned before, when we put the system into walk test, the nightlight comes on. And the reason for that is because the normal green LED for this detection device will come on when it gets a signal back from the transceiver. So if it's a fair way away from the transceiver and there might be, say, a 1 or 2 second delay before that LED comes on, as people are walk testing, it makes it a lot harder for walk test to know exactly when the beams are. So by having the security nightlight on, and then when you walk test to the M1, that security nightlight will come on bing each time it detects. That makes it a lot easier. We've also got the tamp, and the same as one way, we've got 2 batteries in there. So if you're going to use the security convenience light, then the second battery is used for that night light, where the first battery is used for the PIR itself. If you turn the security convenience light off, so you're not going to use it, the second battery then becomes an additional battery for the life of the PIR to get twice as much battery life with the PIR. We can control that. For those who are familiar with the M1, is that on the main board, we've got outputs 1, 2, 3, and then we start at output 7 to 16. There is no outputs 4, 5, and 6. We're now using output 4, 5, and 6 for the security nightlight. So if you've got the security convenience nightlight on that detector, we can now control it from the M1. So it will come on, of course, if someone walks into a dark room, even if it's not controlled from an M1. But there's some times that you want to control that as well, maybe when you want to turn it on a bit of a nightlight to help with cameras or something like that, to tell the person that they've been detected, to help during exit time. So if we turn output 4 on, whenever output 4 is turned on, then that security nightlight will come on for about 17 seconds. So if we say, right, when the night dark outside, in other words, when the particular time of day on an M1, we turn output 4 on. Now that nightlight will only come on when you walk in front of that detector. So it's not going to be on all the time. It'll then, as you walk in front of the detector, the nightlight will come on for 17 seconds. And every time the PIR gets reactivated, it will re-trigger that output nightlight, security nightlight. If you turn output 5 on, the detector then detects the LED or the security nightlight on the detector will now start flashing. It flashes for every time it's detected, it flashes for about 30 seconds. So as an example we've got here is if the telephone's ringing, you might flash that, turn output 5 on, and then when the detector activates, it will then start flashing that light. Now it doesn't come on instantly. As soon as you turn output 4 and output 5 or output 6, etc., they don't come on. You've got to walk in front of the detector. And the reason for that, of course, is that the detector is not transmitting. It's transmitting when you detect, so therefore it's virtually in sleep mode, so it's not going to get the signal back that says, hey, output 4 is on, until it transmits, and then it says, oh, output 4 is on, okay, I'll turn my night light on. So as it goes over the tech tip on the right-hand side, in some instances, in worst case, even after detecting, you might have to wait up to 8 seconds before it activates. That's worst case. Usually once you got output 4 on, you then move in front of the detector, the night light will come on within 1 or 2 seconds. So it's just a help for convenience that you might want to turn that light on when it's not quite dark as walking into a real dark room, so you've got control over it. We've also got a new wireless smoke detector for the two-way. It's a photoelectric smoke detector, but in addition to that, we've also got a rate of rise and fixed temperature in that as well. So you've virtually got 3 detectors in one: smoke, heat of rise and temperature in there, rather than just your normal smoke detector. And looking at the back of it, it's much the same as the PIR. We use the same battery. There's 2 batteries that can fit in the detector. And the other thing is that you can't replace the back cover on the detector unless the batteries and the battery cover is in there. So if you haven't got the battery cover in there, which pushes that little needle here, then you can't put the back on. So people can't accidentally put the detector back in place if there's no batteries in place. So that's just help for obviously safety aspects. So within the range of the two-way at the moment, we've got obviously the new 4-button radio key. There's the standard detector and the PET detector. There's the wireless smoke detector, slimline read, and the micro read. And as I mentioned, coming soon will be a 3-zone read switch, or 3-zone general purpose transmitter, I guess. Now, for programming the sensors into the M1 itself, for those who are familiar with the one-way, you'll notice that this programs in almost identical. However, with the one-way, reality is that you can really only program it in via the keypad. You can't program it in from the via RP software. However, with the two-way, you can program it in via the keypad and via the software itself. And we're going to show you how to do that. Programming in even from the keypad, it's almost identical to the one-way, but there's an additional step that we have to do. So let's have a look at programming it in from the system keypad. One thing you've got to do is make sure when you're programming from the keypad, make sure that you don't have RP connected to the panel. It's got to be disconnected, otherwise it's going to be difficult to upload the data into RP later on. So with RP not connected, we can go into the keypad. We're going to same with whether you're using a navigator keypad or whether you're using the LCD, it's exactly the same. It's easy to show on the screen here with the navigator, is that you go into install program mode, wireless setup, exactly the same as you did with the one-way. You then go up to the next option, up to option number 3, and when you get to option 3, which is Learn Transmission Device, you hit the select button. So at the moment it's identical to the one-way. You then select the zone you want to program in, and being usually at address number 2, which it should start at, it starts at zone 17. So you can either manually type in zone 17 or use the up and down to get to the zone that you want. So if you want to start at zone 25 or whatever, you can type in 025 or go up to the next zone, or obviously the zone that you're on. You then press the Learn button, still exactly the same as a one-way, and then what it'll come up with is push transmitter button. It'll tell you to push the transmitter button to learn it in, and obviously via the M1 speakers, push transmitter button to learn for zone 17. If it's a radio key, it's exactly the same as the one-way. You hit the on and off buttons together, and that will send a learn code in. Or if it's a detection device, whether it be a read switch, PIR, smoke detector, etc., you just again put the batteries in. When you put the batteries in, then it sends a learn signal into the M1. Once the learn signal is sent and received, then it will show the code that was learnt in to the M1. So again, exactly the same as what we do with a one, and it will automatically increment. So if that was zone 17 that we learn in, it will automatically advance to the next zone, automatically go to zone 18. You can then put the battery in the next device. It'll automatically move on to zone 19, put the battery in, 20, put the battery in without you touching the keypad. You can just go one after the other, after the other, after other, etc., till you've learned all the devices in. Now with the two-way, there's one extra step now we have to do that we never had to do with the one-way, and that is that once it's been enrolled, the device, we then have to hit the HW or hardware button, and when we push that, we now have to program the loop number. At default it'll be a loop 0, so we use the right arrow key to move the cursor under where it says loop 0, and then we have to put an associated loop number in. If it's a radio key, then that can stay at loop 0. If it's a radio device, whether it be a read switch, PIR, smoke detector, etc., then that must be changed to loop 2. When the 3-button device comes out, don't know if you picked up, but it had loop 1 and loop 3 on there. So the main read switch on that three-way will be loop 2 as default, which you'd have to put for loop 2. But when you learnt in, you'd go to the next zone, then that's got to be loop 1 or loop 3, depending which hardwire you're going to put in. But until that comes out, for all the effective purposes now, is the radio key, it will be loop 0, and radio detection devices you must put to loop 2. If you leave the radio detection device at loop number 0, they won't detect, they won't work at all. If you put a radio key on loop 2 by mistake, won't matter, because the radio key doesn't matter. We just say to leave that at loop at 0 and the others at 2. So that's a little step that you have to do that you didn't do with the one-way. Once you've finished programming, you can either go to the next zone and do the same with the next zone, or you just go back to select wireless zones, and that then gets you out of programming. We'll now show you how you can program the radio transmitters in via the software, which you couldn't do with the one-way. The first thing you need to do is, as you would have done with the one-way, you first of all got to add the group, the wireless transmitter. To do that, you right mouse click onto zones and go new wireless zones. You then select the zones that you want. So in this case, because you've got to start at address number 2, they will be at address 2. If you had more than 16 zones, you would then add another one, another 16 zones, another 16. Even if you've only got one receiver, you could then still go and add the zones that you want to add to get the number of zones that you're activating. Keep in mind that, the M1 will support 144 zones of wireless with or without additional radio receivers. So you just, as I said, just go and check add the extra zones. So if we're getting a radio key in, we then select the zone that you want to program it in. In this example, I'm going to program it in on zone 17. So I select zone 17 under my wireless group. We then give that radio key a name. On this example, I'm just going to call it radio key demo. We go down to the definition and we select the definition being a radio key fob, or just a key fob as the definition. We then go to wireless setup, and when we go into wireless setup, the first thing we need to do is to check it that it's, to enable that device, so it's going to work, of course. We have to make sure, because it's a radio key that can be taken off site and it doesn't send supervision, we make sure that the not supervised option for supervision is selected. Obviously, if you leave that at normal supervision, then the next day the customer is going to get a loss of radio detection device because that radio key isn't on site anymore. It hasn't been activated. So you make sure for radio key it's not supervised. We now have an option under some special condition. Normally, in programming of an M1, the buttons are programmed as button 1, 2, 3, 4. If we select option 1 on, then under some special circumstances, those 4 buttons under programming for this radio zone or the radio key, those buttons, instead of programming it in the M1 programming as button 1 to 4, they're now programmed as 5 to 8. So we now get some additional programming if you wanted to use that. Under the key fob number, all of them are defaulted at user ID 99. But you can program that to match perhaps a user's PIN code, or alternatively you can even map it to something else, or can take it up to code number 204 up to 255. So even though you can't, if you set this radio key fob, for example, as number 210, even though you can't put a name to it like you could if you named it at, say, 110, you can still use it, so you'll know that key fob number 210 armed or disarmed the system. So you've got that the same as you did with the one-way. Now, to program in the TXID in the system, normally with one-way, once we learnt it in via the keypad and we upload the data, it would automatically populate this data in here for us. But if this was a new system and we're now programming it in via the RP software, not programming it in via the keypad, we can manually type that TXID in. And where we get that from, on each transmission device, there's a sticker on the back and will tell us what the TXID is. It almost tells us what the TXID is. There's actually a 7-digit number in there, and in the TXID field, we don't use that whole number. What we use is the first digit and the last 5 digits. So the second and third we don't use. So therefore, under TXID, for this example on the left here with the radio key fob, I would type in F9278A. I wouldn't put the 1 and 0 in. So the first number and the last 5, and then RP will automatically put a 0 at the start of it to buffer that out, and that's the number you would put in. The DL and HID numbers would automatically be entered once as you're putting that number there in. On this example, if it's a radio read switch, again, the first number, in this case it's an A, and then 9269C would get entered in there. First digit and the last 5 digits. And in this case, the PIR, we put the first digit being a 4 and the last digits being 9316A. So that's how you just instantly look at the code there. So before you mount a read switch, before you mount a PIR or whatever, it's a good idea to get that number off the device before you mount it. Otherwise you'll curse when you've got to take it off to get that transmitter ID, or obviously you've got to then learn it in via the keypad. Okay, so they're just going back as a recap of what we said. First digit and the last 5 digits, and that's what would be entered, and RP would automatically put a 0, or you can put it. So once you've learnt that, put that TXID in, you then, because it's a radio key fob, you leave loop 0 set for 0, hit save, and that radio key fob would start working. It would start as default, arm and disarm the panel, and button 3 and 4 are not enabled on the system, but 1 and 2 for arm disarm are enabled. Bang, it starts working. If we're going to learn a radio read switch in, on this example I'm going to put a radio read switch into zone 18. So I select zone 18, I then go up to the name, we give it a name. In this example I'm going to put it read switch front door. We then go to the definition, whether you want to have it as a perimeter, whatever you're going to put that zone, exactly the same as you would as a hardwired. What area, is it going to be forced arm, etc., etc. So you select all the attributes and the definition exactly as you would a hardwired zone. And again, go into the wireless setup. It's much the same as the key fob. We enable it. Under now the supervision, we can leave it at normal supervision or turn supervision off, whatever tickles your fancy. But they're all read switches are supervised, so we can leave the supervision on. The options don't matter for read switch, so we leave all those off. The key fob user ID, again, it's not applicable because it's not a radio key fob, so we leave that. No matter what you change, it's not going to matter. And again, exactly the same under the TXID. We look at the sticker, the first digit and the last 5 digits. So in this case, A9269C, because obviously every transmission device would have a different TXID on them, which is a code in there, and put that in. And then because it's a detection device, that needs to be, the loop needs to be set for loop 2. Okay, so you put that at loop 2, save, and the read switch will then start working. The PIR, when we're putting a radio wireless PIR, in this example I'm going to put it on zone 19. So we go down to zone 19, give it a name. In this example it's an entry PIR. You set the configuration for it, whether you're going to have entry exit, it's going to be a follow, it's going to be whatever you want it to work for. Set the attributes exactly the same as you would a hardwired, forced arm, chime, or whatever you want it to be. We then go up to the wireless setup, click on wireless setup, and we program again exactly the same as we did the other devices. We enable it. The supervision we set to normal supervision or turn it on. Again, it's a supervised device, so you can leave it set for normal supervision. You don't set this as a PIR. This device is a PIR for auto restore. This one is more as a legacy from the one-way, so you don't have to select this device as a PIR. For the two-way, you can leave that blank. Again, the radio key fob, it's not applicable because it's not a radio key, so it's not applicable. And the TXID, again, exactly the same way. You put the first digit, which is a 4. Most PIRs start with a 4. Key fobs start with an F, etc. So it's a 4, and then the last 5 digits, 9316A. So the first digit and the last 5, that's on there. So second and third wouldn't be entered. And again, being a detection device, we put that to loop 2. So as you can see, programming it from the RP software can be a lot easier because all you have to do is enable it, check the supervision, put in the TXID and the loop number, save it, and the job's done. If we go under wireless setup, we just select the zone wireless setup. You can see the 3 devices that we've put in. You can see they've enabled what the supervision set for, any option boxes. The hardware loop is 0 for a radio key, and they're all 2 for detection devices. As we then click on key fob events, if it's a radio key fob, there are 4 buttons, 1, 2, 3, 4. So as default, button 1 is to arm away, button 2 is for momentary. If you don't want to use those for arming and disarming, You can disable them here and enable them under rules to use them whatever you want to do, and therefore you can have any button that can be used for any other application the same as you could one way. The button 3 is the inquiry button, so if you give it a short press, it's going to tell you, the LED is going to tell you the status of the alarm or that area that this key fob can control. And if you want to use that for activation and you've got something programmed in for button 3 here or under rules for button 3, when you push and hold that button 3 for more than 4 seconds, it will then activate the event. The other thing with confidence level is with a wireless PIR, how do I know that after I've programmed it and tested okay today, how do I know it's going to be still working tomorrow? How do I know, like on a lot of the one-way shit, the hope and pray, we're sending heaps of signals out. We hope that one of them gets through. We hope the wind's not blowing the other direction and someone's shut a door in between, and, how do we know? So the good thing with the two-way wireless is the confidence level can be turned right up high. And the reason for that is when a battery is first connected into a detection device, and this is a good idea for testing obviously, is that for the first 10 minutes of that detection device being powered up, 10 minutes, we run at half power. So the signal strength being transmitted out of that detection device is only half power. So when you're walk testing, you put the batteries in, you walk test. If the signal gets through to the transceiver, then after 10 minutes time, we're now going to go back to full signal. So tomorrow that is going to work, because if it worked fine on half power, it's going to work twice as good on full power after that 10-minute test mode. So even though you might have learnt them in and they all working good, etc., it's a good idea when you do your walk test, just take the batteries out of the devices, then go into walk test mode, take the batteries out, wait 30 seconds, and whenever you're changing the batteries, you'd also do that as well. When they take the batteries out, wait 30 seconds for the device to completely discharge, put the new battery, or put the batteries back in, or if you're replacing the batteries, put them in. For the first 10 minutes, they'll run at half power. You do your test, and therefore, as I said, you'll know that it's going to be working fine. So, why customers want two-way? What's the convenience, or what's the advantages for you? Obviously, the convenience of the two-way fobs, that you can tell the system's arm disarm. You don't have to be chirping the sirens and annoying all the neighbours or whatever. Increased confidence, because two-way wireless works more like a hardwired, in the sense that you'll know whether the signal got back. You've got some supervision. It's got the frequency hopping that will go through. A PIR even, you can have it set for virtually no sleep time if you didn't want to. You've got increased reliability, so it's more secure, whether it be in for home or business. Extended battery life, because you're not sending 20 or 30 signals when a detection device activates at full power. You're only sending 1 or 2 signals, and then at low power, and it's got frequency hopping. If it didn't get a reply back from the transceiver straight away, it frequency hops and sends another one, etc. So you've got extended battery life, and it's a lot more secure, and obviously the confidence levels there. So any questions at all? I notice that some have come through, so just let me cycle through and we will answer any questions. I think the first one we asked was, what's the difference between the M1 and the transceiver? As I mentioned before, typical 1.2 kilometres on the data bus, and you can put multiple receivers. So you've got a large factory, large school or whatever, you can put multiple ones around. And each transceiver, as I said, we still say industry standard 50 metres, but there's a good chance you'll get double that in majority of cases anyway, from the detection device to the transceiver. Yeah, how does output 6 work, etc., or output 4 work if the PIR is in sleep mode? If you've got a long sleep mode, then you're going to still have the same issues. If the detector's in sleep mode, then it's not going to work. You'd have to wait till it goes out of sleep mode so it can transmit back to the transceiver. So if you're going to use output 4, 5 and 6, that you want the night lights or security light to come on, then you turn that dip switch on the PIR to a short sleep time, and then it works much the same as a hardwired one. So as soon as you walk in front of it, it's going to give a quick transmit, because again, we're only sending one signal. We're not sending about 20 like we have to do with one-way and full power. So the battery life of the detector is still not going to be affected. How do we eliminate, do we have any estimated battery life on the wireless devices? It's only a guesstimate, but as a PIR, we're looking typically at 5 years plus. If it's a reed switch on a door, front door, for example, again, you might get 5 to 6 years. If it's on a back door that is hardly ever opened, on a window that's hardly ever open, then it's really the shelf life of the battery itself, which is typically could be 8 to 10 years battery life on there. So that's just an estimate. We do have some scientific data from graphs and calculations and that we've done, and that pretty well supports that life of typically, you know. Is there any other questions at all that you might have? And are these support documents available? Support documents as in got a technical document for battery life, but you've got to read it with almost a engineering degree. Yes, so we do have that available, and obviously we've got manuals and that on the product. All right, any other questions at all?